How do we find the median in the interval series? First step is to find the class which contains the median. The median is placed in that class. I remind you that we are talking about the interval series with classes. The median is placed in that class where the cumulative frequency, if we perform on the frequencies, where the cumulative frequency exceeds a half of the population size for the first time. So we are looking for this NIS, the cumulative frequency, which exceeds the half of the population for the first time. Exceeds means to be greater than n divided by 2. And after that, we move on to the computation of the median, and all the categories are known to you. X0 is the lower bound of the median class, n is the population size, ns minus 1 is the cumulative frequency from the class that precedes the median class, and n0 is the frequency of the median class, c0 is the range of the median class. If we talk about the relative frequency, median is placed in that class where the cumulative relative frequency exceeds a half, exceeds 0.5 for the first time. Yeah? Cumulative. The cumulative relative frequency is higher than half for the first time, and this is the median class. Median is equal to x0 plus 0.5 minus the frequency, the cumulative relative frequency from the class that precedes the median class. F0 is relative frequency of the median class, and here we have the range of the median class. This formula is the consequence of transformation of this formula in the assumption in which the population size goes to the infinity. Yeah, we can prove that divide denominator and numerator and denominator by n, and n approaches to the infinity, and we will receive this kind of formula. All right, we can move on to the next slide. An appropriate example that show you how to find the median in well-known interval series from the previous classes. So we consider the variable age. We have 6 classes, and as we know, the middle value, yes, is somewhere between 0 and 70. Yeah, we, on the basis of the information of cumulative frequency or cumulative relative frequency, we are able to find the appropriate class which contains the middle value, the median. Let's start with the frequencies. We know that the population size is 171. So the half of the population size is 171 divided by 2. It's 85.5. And now we are looking for the class in which cumulative frequency exceeds the half of the population, exceeds the value of 85.5 for the first time, going from the top to the bottom of the table. If 7 exceeds 85.5 for the first time, if 7 is greater than 85.5, of course not. 19, no way. 64, no. 126. Yes, this value is for the first time greater than, strongly greater than 85.5. So here we have the zero level in which we have the median. Median is somewhere between 41 and 50. On the basis of this information, we are able to compute median here. Median is x0, the lower bound of the median class, which is 41 plus a half multiplied by the population size 171 plus 1 minus cumulative frequency from the previous class, from the -1 level, and this is 64 divided by n0, the frequency from the median class 62, and this fraction is multiplied by the range of that class, 50 minus 41, and the final result is, it's your turn. Please compute this amount. Okay, but if we want to perform on cumulative relative frequencies, we are looking for the class in which cumulative relative frequency exceeds a half for the first time. So we are looking for the value, going down in the table, in which we have the value greater than 0.5 for the first time. Here, no, 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 yes. Yes, this value is greater than 0.5 for the first time. So, of course, we have similar categories, 41 plus, and here we have simple, a half minus relative cumulative frequency from the previous class, from the -1 level, which is 0.374, divided by, here we have f0, oh here, sorry, here we have f0, 0.363, yeah, and this fraction is multiplied by 9, of course. Yeah, please compute this amount. Of course, we assume that here n is huge a number, so there will occur differences between the results. The process of finding the first and the third quartile in the interval series are very similar to the previous one. If we talk about the first quartile and the frequencies, we are looking for the class yeah, first quartile is placed in that class where the cumulative frequency exceeds a quarter of the population size. A quarter of the population size. First quartile means 1/4, yeah, of the population size. If we talk about the third quartile, we are looking for the class in which cumulative frequency exceeds 3/4 of the population size. 3/4 of the population size. If we use the relative frequencies, we are looking for the class where the cumulative relative frequency exceeds a quarter, 0.25, exceeds simply 25%. Yeah, if we talk about the first quartile for the first time. And if we want to find the third quartile, we are looking for the class in which the cumulative relative frequency exceeds 3/4, 75%. Here we have the example. We know that the first quartile is placed in that class in which cumulative frequency, now let's use cumulative frequencies, in which cumulative frequency exceeds a quarter of the population. A quarter of the population, 25% of the population, in our example, is 171 divided by 4, 42.75. So, we are looking for the class in which cumulative frequency exceeds 42.75 for the first time. Here we have lower value than 42.75, so we are moving down. Here also we have the value lower than 42.75, so we are moving down. Here 64 is greater than 42.75. Yeah, so we have found the zero level, the class of the median of age. Yeah, here we have first quartile of age, of course, not median. Oh my god. Okay, it's the class of the first quartile. The computation will be following. X0, the lower bound of the first quartile class, is 31 plus 1/4, the population size 171 plus 1, minus what? Minus cumulative frequency from the previous class, from the -1 level, 19 divided by n0, 45, multiplied by the scope, the range of the class, which is 9. Please compute it at home. Okay, and maybe let's focus on the third quartile where we use the relative frequencies. Yeah, so let's change the stuff on the interest. Now we are interested in the column of cumulative relative frequency. We are looking for the class which contains the third quartile of age. It means that we are looking for the class in which cumulative relative frequency exceeds 75%, 0.75. Here, no, 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 because we are looking for the value that is greater than 75%. Here, yes. So fifth class is the class of third quartile. Yeah, third quartile is somewhere between 51 and 60. This is our zero level. For this reason, we have what? X0 is 51, the lower bound of the third quartile class, plus 0.75 minus the cumulative relative frequency from the previous class, 0.737, divided by F0. F0 here is the relative frequency from exactly the class of the third quartile, 0.181 multiplied by 9. And we will receive the value of third quartile of H. Please check it out at home. This is your homework, unofficial homework. This is the right time for a real example based on the real data. Here we have COVID-19 death distribution and total death distribution in the US. And the data comes from October 2020, so this is the most recent data. Here we have our variable age and its intervals. Here we have number of persons died due to COVID in the US from the beginning of the year. And here we have all deaths distribution in persons from the beginning of the year. All deaths due to different reasons, different various diseases. And here we have the computation of relative frequencies using two methods. Using spreadsheet Excel and using calculator. Here, in the situation when we use Excel, we are very accurate because here we have the decimals, and because Excel is very accurate, it saves in its memory complete expansion of the decimals, but it shows only the 3 places after the dot because that's how I determined it. For example, let's take the first value of relative frequency for all deaths in the US, persons between 0 and 17 years. How to compute it? We compute the ratio between 23,357 and this number, total deaths from the beginning of the year. And the ratio is following: 0.010, okay, but after that we have 0, 2, 2, 7, 6, 4, and so on. My calculator is running out of the possibilities. Yeah, but Excel is very accurate. It saves its memory the complete expansion or the almost complete expansion of this decimal. So the sum the sum of these columns are equal to 1, so the sum here is consistent with the theory. But if we perform on the calculator, we save only the approximation of the values of the relative frequencies. Like here, 3 places after the dot. So sometimes we can meet following situation when the sum of all relative frequencies is not consistent with the theory, is more or less than 1, is close to 1, but it's not 1. It's very usual situation, so don't worry if you have the result different than 1. It's normal situation if we use the approximation scheme. We are a little bit inaccurate here. We must accept that fact. Of course, if you compute some measures, your results can differ from the results made by Excel. And sometimes, I must be sincere, sometimes I'm lazy and I give you the results that I have made in Excel spreadsheet. Yeah, so it's possible that you have some different results from my results made in Excel, but it's okay, don't worry. Okay, let's compute and interpret median of age, the first quartile of age, and the third quartile of age of death due to COVID-19 and death due to a variety of reasons in the US. If we talk about the COVID deaths, we express the phenomenon using frequencies, the number of deaths, and here, if we talk about the all deaths that due to a variety of reasons, we use the decimals. So we will use two types of the formulas. Let's start with COVID-19 deaths. So we focus on this column. We just forget for a moment about the all deaths. The first step in the computation of the median and first and third quartile is to compute a cumulative frequencies. Yes, is to compute cumulative frequencies, because we will look for the class in which we have the median, in which we have first quartile and the third quartile. We need the category of the cumulative frequency. First cumulative frequency is equal to the first frequency, which is 111. The next one is the result of adding 111 plus 944. This is 1055. And the next numbers are, of course, I'm lazy, I want to be effective, so I use here my computations made by Excel. 10,006, 9, 44, 665. Of course, you can check it out. Alright. And the last one is, of course, the last cumulative frequency is equal to the population size. Okay. And now we are able to compute, in example, the median. As you know, median of age of COVID victim is described by the formula x0 plus a half multiplied by, in a bracket we have n plus 1 minus ns minus 1. It means the cumulative frequency from the class that precedes the class of the median, divided by n0 multiplied by the range of the class. Okay, and we know that median is inside the class in which cumulative frequency exceeds a half of the population for the first time. We need a half of the population. Population size is 212,328. I need a half of this number. And a half of this number, a half of the population size is 106,164. This is the half of the population. And now I'm looking for the cumulative frequency which exceeds a half of the population for the first time. Of course, my starting point is the first class, and I'm going down and look for the appropriate value. This number is less than 106,164, so I'm going down to the next class. No, it's not higher. No, no, no. Yes, here we exceed the half of the population for the first time. Yes, this number is for the first time bigger than this number. So here we have the class of the median of age of COVID-19 victim. Therefore, let's compute median here. Median here is equal to x0 is the lower bound of that class, of the median class, 75. Yes, this is our zero level. 75 plus a half multiplied by the population size plus 1. Population size plus 1 is the following number. And we subtract what? Cumulative frequency from the previous class, 96,160, and divide the nominator by n0. N0 is the frequency from the median class, 56,409, and the fraction is multiplied by the range of that class, the range of the median class. The range is a difference between upper bound of that class and lower bound of that class. Alright, and the partial results are following. Here we have 75 plus what? In the nominator we have what? 2, 1, 2, 3, 1, 9 multiplied by a half minus 9616 15,548.5. Here we have 56,409, and here we have 84 minus 75. Of course, it's 9. Yeah. And the final result is wait a second. The final result is 77.481 years. What does it mean? It means that 50% of COVID-19 victims in the US are not older than around 77.5 years. Without bracket, it's not necessary. Yeah, 50% of COVID-19 victims in the US are not older than around 77.5 years, and simultaneously 50% of COVID-19 victims in the US are not what? Not younger than around 77.5 years. All right, we can now compute and interpret first and the third quartile. Let's begin with the first quartile. We need what? We need a quarter of the population. A quarter of the population is 2, 1, 2, 3, 2, 8 divided by 4. It is 53,082. This is a quarter of population. First quartile is placed in that class in which cumulative frequency exceeds a quarter of the population for the first time. Here we have for the first time the number that is greater than 53,000 for the first time. So this class is the class of the first quartile of age of COVID-19 victim in the US. Okay, we can repeat the formula. X0 plus 1/4 of n plus 1 minus ns minus 1 divided by n0 multiplied by c0. And what we have here, we change the zero level. Yeah, here we have the zero level, the class of the first quartile, and we see that 65 is the lower bound of the class of first quartile plus 1/4 of the population size. 1/4 of the population size. 2, 1, 2, 3, 2, 8. Population size plus 1, of course. 2, 1, 2, 3, 2, 9. Yeah? 2, 1, 2, 3, 2, 9 divided by 4 minus. Okay. Minus what? Minus the cumulative frequency from the previous class, 44, 6, 6, 5, yeah, divided by the frequency from the class of the first quartile, 45, 9, 5, 1, and multiplied by C0. This is the range of that class. It is the same as in the previous case. It's 9. Okay. So the final result is following. Approximately 66.648 years. What does it mean? It means that 25% of COVID-19 victims in the US are not older than around 66.6 years. Very dangerous number. 66.6. Okay. It also means that 75% of COVID-19 victims in the US are not younger than around 66.6. But this version of the interpretation is more interesting to us. Alright, so we can move on to the third quartile. We need what? We need 3/4 of the population. 3/4 of the population size. As you can see, the changes, the differences between the formulas are quite small. Yeah, here we change only the fraction, yeah, and the number, and that's all actually. All right, wait a second. Please keep calm. All right. Here we have third quartile, and here we have 3/4, and that's all. Yes. We can describe the universal formula. Yeah. Here we have the only change. Yeah, the change of the fraction and change of the symbol of the measure, and that's all. Here we have 3/4. 3/4 of the population size is 2.212328 multiplied by 3/4. It is 159,246. It's it's 3/4 of the population size. Okay, so we are looking for the class in which 3/4 of the population is exceeded for the first time. No, 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 of course, no. Here, no. Yes, this is the last class. Here we exceed the 3/4 of the population for the first time. So the last class is the class of the third quartile. So now we are able to compute it. Naturally, we have what? Here we have the 0 level now, and if x0 is determined by 85. Here we have what? Population size increased by 1, 2, 1, 2, 3, 2, 8 plus 1, multiplied by 3 and divided by 4. The final result is 159,246.75 minus cumulative frequency from the previous class, 147,025, divided by the frequency from that class, 65,303, and multiplied by the range of that class. The range of that class is a little bit different than in the previous cases. 109 minus 85, 24. Here we have the information about the oldest victim of the virus. It was 109. You can check it out. Here you have an appropriate source. Okay, so we can give here the final result. Minus 14705, yeah, divided by 65,303, multiplied by 24, and plus 85. And we have what? 89, of course, approximately 89.492 years. So it means that 20, please write it down, of course, 25 of the, actually, we can put it here, 25% of the COVID-19 victims in the US are not younger than around 89.5 years. So the group of the 25% of the oldest COVID-19 victims are characterized by the age not younger than 89.5 years. Yeah, 25% of the oldest COVID-19 victims in the US are not younger than around 89.5 years. Alternative interpretation of that amount, because here we have our population in point of view of age from 0 up to 109, yeah, and we see that here we have third quartile, which is about 89.5 years, and 25% of the population, 25% of the oldest COVID-19 victims are characterized by the age not lower than 89.5 years. Here we have 25% of the oldest victims. Their age is not lower than 89.5 years. Well done. Let's analyze now the median, the first quartile, and the third quartile of age of all deaths. First step is to compute the column of cumulative relative frequencies, because now we perform on the column with the decimals, with the percentage of the group age in total deaths, and we need FIS, the cumulative relative frequency, which will be computed on the basis on this column. So, in that way, the first cumulative relative frequency is equal to the first relative frequency, 0.01. The next one is the first cumulative relative frequency plus the second relative frequency, 0.029, and the rest of the numbers are following: 0.096, 0.261, 0.459, 0.701, and finally 1. Yeah, I made it using a calculator, and fortunately we have the results which are consistent with the theory. The sum, the last cumulative relative frequency is equal to 1, so everything is okay. All right, so we know that the median of age of all deaths in US can be described by the formula x0 plus a half, yes, because we perform on the frequencies and relative frequencies and cumulative relative frequencies, 0.5 minus fs minus 1. The frequency, the cumulative relative frequency from the previous class that precedes the class of the median, f0, relative frequency from the median class, multiplied by c0, the range the range of the class of the median. How do we find the class of the median? On the basis on the information from the column cumulative relative frequency. We are looking for the value that exceeds a half for the first time. And we notice that in the 1, 2, 3, 4, 5, 6, in the sixth class we exceed a half for the first time, 50% for the first time. So this class is a class of the median of the age in the group of all deaths. We can compute now our median. Our median is equal to, this is the zero level, so x0 is 75 plus a half minus the cumulative relative frequency from the previous class, 0.459, divided by f0. f0 is placed here, it's 0.242 multiplied by the range of the class. And the final result is a half minus 0.459 divided by 0.242 multiplied by 9 and plus 75. It's 76.525 years. The interpretation will be following. 50% of total deaths in the US, 50% of dead people in the US, 50% of dead people in the US are not younger or not older than about 76.5 years. All right. We can also compute the first quartile of the age of death due to a variety of reasons. It is, but first we should determine the class of the first quartile. The class of the first quartile is that class in which we exceed 25% for the first time. We start with the first cell with the first row, and we are moving down, and we are looking for the class in which we exceed 0.25 for the first time. No, yes. So here we have the class of the first quartile. So we are able now to make some computations. Here we have new zero level. Here we have new zero level, and we start with the lower bound of this class. This is 50 plus 0.25 minus cumulative frequency from the previous class 0.096 divided by f0. F0 is 0.165 multiplied by the range of that class. The range of that class is the difference between 64 and 50, so this is 14. And we can compute our measure. 25 minus 0.096 divided by 0.165 plus multiplied by 14 plus 50. And finally we have the final result 63.067 years. So the interpretation is following: 25% of debt in the US are not older than around 63 years. 25% of the youngest dead people in the US are characterized by the age not greater than around 63 years. This is the appropriate interpretation. Okay, and the last measure is the third quartile. Third quartile is placed in that class in which cumulative relative frequency exceeds 75% for the first time. 75%. Third quartile means 3 quarters. 3 divided by 4, 75%. Okay. Now, at this stage, we are looking for the class in which we have the value greater than 0.75 for the first time. Here, and actually this is the last time when we have the number greater than 75%. This class is the class of the third quartile of age of all deaths. Okay, so we change the zero level, and now we have what? X0 is the lower bound of third quartile class, 85 plus 0.75 minus cumulative relative frequency from the previous class, 0.701, divided by F0. F0 is almost 30%, 0.299, multiplied by the range of that class, as you remember, 24. Alright, let's take the calculator, compute these simple amounts. And the final result is 88.933 years. We need the interpretation of this measure. 25% of the oldest dead people in the US, the US are not younger than approximately 89 years. Years. This is our interpretation. Let's compare the results. Here we have a summary table which contains something like a juxtaposition of the measures. As you can see, general trend, general regularity can be perceived here. Namely, the measures related to the COVID-19 victims are generally higher than the measures computed for the ALF deaths. It means that COVID-19 victims tend to be older than all deaths overall. In other words, COVID victims tend to be older than the dead for a variety of reasons. It means that in this manner, people older than usual die because of COVID in comparison with all deaths. So we confirm that the virus is the most dangerous for the oldest people.